Okay guys, let's begin our discussion over the CBSE pattern question exercises for relations and functions for class 11th. Now in here we have the first question for 1 mark. Let f be a function from collection of all reals to collection of all reals given by the rule fx equals x square plus 3. Find the preimage of 39 and preimage of 2 under f. Now f is a function given from collection of all reals to collection of all reals such that fx equals x square plus 3 for all x coming from the domain of f, which is collection of all reals. I need to find the preimage of 39 and preimage of 2. There is no guarantee that their preimages is existing or not, or exactly one preimage is existing or more than one preimages are existing. Everything we have to verify, but first thing that the question is valid. Preimage of 39, preimage of 2, that means 39 and 2 should be members of the codomain, which they are. Codomain is collection of all reals. 39 and 2 are very much real, and therefore the question of even asking that their preimages exist or not is a valid question. I am saying let x be the preimage of 39 under f. This implies x is the preimage of 39 under f, means f is mapping x to 39. That means under f, x is mapped to 39. Image of x is 39 under f, that means x is preimage of 39 under f. That is the relationship between image and preimage. So if x is the preimage of 39 under f, that means image of x under f is 39. F of x is given as x square plus 3. This is 39, which implies x square is 39 minus 3, that is 36, which implies x is plus minus 6, which very much belongs in the domain of f, that is collection of all reals. Therefore, 39 has two preimages. 39 has two preimages under f, that is 6 and minus 6. Now if I talk about preimage of 2, I am saying also let x dash be the preimage, let x dash be the preimage of 2 under f. That means x dash is a member of the domain which under f is being mapped to 2. This implies f of x dash is 2, that is 2 is the image of x dash under f. F of x dash is nothing but x dash square plus 3 equals 2, which implies x dash square equals 2 minus 3, which is minus 1. Now x dash is a member of the domain of f, that means collection of all reals. Which is that real number whose square gives you negative answer? Is there any real number whose square is a negative quantity? Never. Square of any real number is always a non-negative quantity. So which is a contradiction, as x dash is a real number and there is no real number whose square is minus 1. Therefore, no such x dash exists such that f of x dash is 2, because if f of x dash will be 2, it means that x dash's square should be negative quantity minus 1, which is never possible. That means there is no x dash in the domain of f, which is collection of all reals, which is getting mapped to 2 under f. That means 2 has absolutely no preimage under f. So therefore, 2 has no preimage under f. So this particular assumption of x dash being preimage of 2, that is a contradiction, it's wrong, and therefore 2 has no preimage. So 39 has two preimages, 2 has absolutely no preimage. F of x is given as 3x cube minus 5x square plus 9. Find f of x minus 1. It's pretty simple. F of x is given to you. F of x is 3x cube minus 5x square plus 9. And therefore f of x minus 1 will be 3 times x minus 1 whole cube minus 5 times x minus 1 whole square plus 9. Just replace x by x minus 1. A minus b whole cube is a cube minus 3a square b plus 3ab square minus b cube. So a cube minus 3a square b plus 3ab square minus b cube minus 5, this is a square plus b square minus 2ab plus 9. So you have 3x cube minus 9x square plus 9x minus 3 minus 5x square minus 5 plus 10x plus 9. This gives you 3x cube. Then you have minus 9x square minus 5x square, 14x square. Then you have plus 9x, this is plus 10x, so it is 19x. Then you have minus 3 minus 5 minus 8, minus 8 plus 9 is plus 1. Because we had 3x cube minus 9x square plus 9x minus 3, then minus 5x square minus 5 plus 10x and plus 9. So this is the very value of f of x minus 1 if the given value of f of x is this. Moving to the next question, we have A is given to be the set 1, 2, 3 and B is the set of all those natural numbers which are prime numbers less than 5. If A is 1, 2, 3 and B is all the natural numbers which are prime numbers less than 5. Let's just start counting the prime numbers: 2, 3, 5, 7 and so on. 2, 3, 5, 7 and so on. I am not going to proceed the list ahead. Why? Because I only need those prime numbers which are less than 5, strictly less than 5. That means I am not allowed to include 5. Before 5 lie 2 and 3 as my prime numbers less than 5. So B is nothing but 2, 3. The moment you have decoded B, stuff is very simple. You need to calculate A cross B cross A and A cross B intersection B cross A. A cross B, you know how to do that. 1, 2, 3 cross 2, 3. Each element of set A is mapped to each element of set B. So it is a set of ordered pairs. 1 gets paired up with 2, 1 gets paired up with 3, then 2 gets paired up with each element of set B. So 2 gets paired up with 2, 2 gets paired up with 3, then 3 gets paired up with each element of set B. So 3 gets paired up with 2 and 3 gets paired up with 3. That's the ordered pair sitting inside the Cartesian product of these two sets. Then you have B cross A. B is what? 2, 3 cross 1, 2, 3. Again, each element of set B gets paired up with each element of set A. So 2 gets paired up with 1, 2 gets paired up with 2, 2 gets paired up with 3, 3 also gets paired up with all the 3 elements of set A. So 2, 1, 2, 2, 2, 3, similarly 3, 1, 3, 2, 3, 3. And now I need to calculate the intersection of A cross B and B cross A. That means what all ordered pairs are common in A cross B and B cross A. You can clearly see 1, 2 is not common, 1, 3 is not common, 2, 2 is common, 2, 3 is common, 3, 1 is not common, 3, 2 is common, 3, 3 is common. So there are 4 ordered pairs which are common in both these sets A cross B and B cross A, and therefore A cross B intersection B cross A is set of 4 ordered pairs 2, 2, 2, 3, 3, 2 and 3, 3. Is it clear? That completes our discussion over this question. Next we have G is given to be this. Is this a function? If this is described by the formula gx equals alpha x plus beta, then what values should be assigned to alpha and beta? I actually need to find the exact definition of the function G. So G is basically this function as a relation. That means just pick up all the first components. If you pick up all the first components, you will be getting the domain of G, and if you pick up all the second components, you would be getting the range of G. Basically, this is G function as a relation. Pick up all the first components, you have 1, 2, 3, 4. In here you have 1, 3, 5, 7. Now G is basically doing what? G is mapping 1 to 1, 2 to 3, 3 to 5 and 4 to 7. I can take codomain as collection of all reals. This is actually the range which is strictly contained in the collection of all reals. So here one thing is very much sure. If this is domain of G, then each element of the domain is first of all mapped to some member of the codomain. In fact, each member of the domain is mapped to exactly one member of the codomain. No member of the domain is mapped to two distinct members of the codomain, and therefore G is a function. Clearly G is a function because distinct members of the domain are here. No member of the domain is mapped to two distinct members of the codomain, and each member of the domain is mapped to at least one member of the codomain. So there is no domain member left which has no image, firstly. Secondly, there is no member of the domain which has more than one image. Clear? So it is a function. Clearly G is a function, and I know G is mapping 1 to 1 and G is mapping 2 to 3. These both will suffice to give us the value of alpha and beta. If G of 1 is 1, you know G of x is alpha x plus beta. G of 1 is alpha into 1 plus beta. So it is alpha plus beta is 1, and G of 2 is 2 alpha plus beta. This is 3. So now if you solve, 2 alpha plus beta is 3, alpha plus beta is 1. If you subtract, you get 2 alpha minus alpha is alpha equals 2, and beta will be what? If alpha is 2, 1 minus 2 is minus 1. If alpha is 2, 1 minus 2 is minus 1, so beta is minus 1. So alpha is coming out to be 2, beta is coming out to be minus 1. Next we have A is given to be this. Define a relation R as all those ordered pairs x comma y such that y is equals to x plus 1. Depict this relation using an arrow diagram. Write down the domain, codomain and range of R. Pretty nice question. I have to define a relation R on the set A. That means A cross A. R is a subset of A cross A. So basically, let's see how relation R is mapping elements of set A to elements of set A. See, you have 1, 2, 3, 4, 5, 6 here also, and 1, 2, 3, 4, 5, 6 here also. Now you know that x is related to y under the relation R if and only if y is equal to x plus 1, right? Now x is equal to 1, 1 plus 1 is 2, that means what? 1 is related to 2 under R. So 1 is related to 2 under R. Because 1 is related to 2, why? Because 2 can be written as 1 plus 1. Similarly, 2 is related to 3 under R because 3 can be written as 2 plus 1. X is related to y when y can be written as x plus 1. 3 is related to 4 because 4 can be written as 3 plus 1. 4 is related to 5 because 5 can be written as 4 plus 1. 5 is related to 6 because 6 can be written as 5 plus 1. 6 will be related to 7, but there is no 7 in the codomain. Basically, this is the codomain and therefore 6 is not related to any element. Okay? 6 is that element in A which is not related to any element in A under the relation R. So therefore, 2 is related to 3, 3 is related to 4, 4 is related to 5, 5 is related to 6, 1 is related to 2. Clear? So clearly I have depicted this using the arrow diagram. Write down the domain. Domain of R is basically, if this is my very pattern of relation R, this means R is what? 1 comma 2, comma 2 comma 3, then you have 3 comma 4, then you have 4 comma 5, and then you have 5 comma 6. Collect all the first components in these ordered pairs. You will get the domain of R as 1 comma 2 comma 3 comma 4 comma 5. And codomain of R is completely this set 1, 2, 3, 4, 5, 6, and range of R is all the second components which is 2, 3, 4, 5, 6. range is strictly contained in the codomain. Next question we have, find the domain and range of this particular function. Okay. I have 3 upon 2 minus x square. Fx equals 3 upon 2 minus x square. The moment I am saying this is fx, that means it is a rational function. Rational functions are not defined whenever denominator is equal to 0. So I am saying fx is real if and only if denominator is not equal to 0. That is, x square is not equal to 2. That is, x is not equal to plus minus root 2. If x is not equal to plus minus root 2, only then fx is going to be a real quantity. If x comes out to be equal to plus root 2 or minus root 2, then this expression will not be a real number. So because this expression is not a real number when x is plus or minus root 2, therefore plus or minus root 2 cannot get entry inside the domain. So therefore domain of f is all the reals fine but not plus minus root 2. That's the domain. Talking about the range, I am saying let y equals fx, that's the drill. Y is 3 upon 2 minus x square. So this is 2y minus x square, y equals 3. So you get 2y minus 3 equals x square y, or x square is 2y minus 3 upon y, or x is plus minus root over 2y minus 3 upon y. For what values of y is x belonging to the domain of f? For what values of y is x belonging to this domain of f? The values of y for which x belongs to collection of all reals minus plus minus root 2 are those values of y for which this inside quantity is greater than or equal to 0, because square root of something is real only when that something is non-negative. If that something is negative, then you enter into imaginary quantities which are not real. So for this to deliver you real quantities, this inside thing has to be greater than or equal to 0. So x belongs to domain of f if and only if 2y minus 3 upon y is greater than or equal to 0. Now how do you solve this? You basically try to catch hold of all the critical points. Y equals 0. If you put denominator equals 0, you get 0. And if you put numerator equals 0, you get 3 by 2, right? Now look at the sign, judge the sign. If you put y equals 0, this quantity will not be a real number because denominator will be equal to 0. So I can never accept 0 as equal to y. If I put y equals 3 by 2, I will get numerator 0, denominator 3 by 2, which is 0, and I want 0. So I will be accepting 3 by 2. Fine. Before 0, if you put suppose minus 1, this is negative, negative upon negative is positive. So before 0, you are getting this as positive, here it will be negative and here it will be positive. I actually want non-negative. Here it is positive, here negative, here positive, here not defined, and here it is equal to 0. So therefore, y should belong to minus infinity 0 open, union 3 by 2 closed to infinity. Therefore, range of f is this. Clear? We have decoded the domain and the range. Let's move on to the next question. We have, let A be a non-empty set such that A cross B equals A cross C, show that B equals C. This is a pretty simple question. If I need to show that B equals C, the only drill you need to know is, I need to show B is contained in C and C is contained in B. Firstly, I am interested to show that B is contained in C. Take an arbitrary member in B. Let B belong in B. This implies that A comma this particular B belongs to A cross B for all A in A. You pick up any element A in set A, keep it as the first component, keep this selected B as the second component. This will belong in A cross B, but A cross B is same as A cross C. That means A comma B belongs in A cross C for all A in A. If A comma B is belonging in A cross C, that means second component is coming from the second set, which implies B belongs in C. B was in B, now B is in C. This implies B is contained in C because this small b was arbitrarily chosen from set B. Exactly in a similar fashion, if you wish to show that C is contained in B, what would you be doing? I am taking an arbitrary element in set C, then C comma, or I should better write A comma C belongs in A cross C for all A in A. That's just by definition, right? But A cross C is same as A cross B. So this is belonging in A cross B. This means second component is coming from the second set. So C belongs in B. And C was arbitrarily chosen. So you are getting C is contained in B. Therefore, B is equal to C. Fine. Moving on to the next, we have, let f and g be real functions defined by fx equals root x plus 2 and gx is root over 4 minus x squared, then find each of the following functions. We know f plus g, f minus g have what as their domains, f into g, f by g, ff, gg have what as their domains. So first we need to work upon the domain of f, domain of g, then draw the domain of all these individual functions and then define them. So if I talk about fx, it is under root x plus 2. Clearly, fx will be a real quantity if and only if this is a real quantity, that means this inside thing is non-negative. If and only if x plus 2 is non-negative. If x plus 2 is negative, then root of x plus 2 will be imaginary and not real. X plus 2 is greater than or equal to 0, that means x is greater than or equal to minus 2. X plus 2 is greater than or equal to 0, that means x is greater than or equal to minus 2. This implies x belongs to minus to infinity. Therefore, domain of f is minus 2 comma infinity. Gx, if I talk about, gx is root over 4 minus x square. Again, gx is real if and only if this 4 minus x square is non-negative, which implies x square minus 4 is negative, right? X square minus 4 is what? X minus 2 into x plus 2. This is negative. Now if you talk about this number line, this is minus infinity, this is infinity, this is minus 2, this is 2. If you put any number equal to, if you put equal to minus 2 and equal to 2, you are definitely going to get 0. So we will be accepting x equals minus 2 and 2 for sure because I want 0. What about less than 0? When will this product be less than 0? Well, if you take any quantity less than minus 2 as equal to x, you will get positive answer. From here if you take, then you will get negative answer. From here if you take, you will get positive answer. You can check, and therefore x belongs to minus 2 comma 2 closed interval. This is the domain of G. If domain of f and domain of G we have got, we know that what is the domain of f plus G. Now let me first write domain of f intersection domain of G is what? Minus 2 comma infinity intersection minus 2 comma 2. Clearly this is equal to minus 2 comma 2 closed interval. So when you intersect their domains, you are getting this interval, and therefore now I am in a position to define f plus G. F plus G is a function from domain of f intersection domain of G. That is what is the domain of f plus G? 2 collection of all reals. How do you define it? F plus G of x is fx plus gx. Fx is root over x plus 2 plus root over 4 minus x square. This is your fx, fx plus gx. What about f minus g? It is also defined from domain of f intersection domain of G as f minus g of x equals fx minus gx, which is root over x plus 2 minus root over 4 minus x square. Next I have f into g, which is again defined from the intersection of both the domains of f and g to R such that fg of x is fx into gx, which is root over x plus 2 into root over 4 minus x square, which is root over x plus 2. 4 minus x square is what? 2 plus x, 2 minus x. So this gives you root over 2 plus x whole square 2 minus x, which is 2 plus x into root over 2 minus x. Exactly in a similar fashion, let's calculate f by g, but f by g's domain is what? F by g's domain is what? Domain of f intersection domain of g minus all those x where gx is 0. Let's see when gx is 0. Gx is 0 if and only if root over 4 minus x square is 0. Root of a non-negative quantity is 0 only when that non-negative quantity is 0. That is 4 minus x square is 0. That means x square is 4, which means x is plus minus 2. So from domain of f intersection domain of g, remove all those x's where gx is 0. X's where gx is 0 are plus minus 2. So remove them. This is the domain of f by g. Is it clear? This is the domain of f by g. When you remove plus and minus 2 from this closed interval, you actually get open interval minus 2 to R such that f by g of x is fx by gx, which is root over x plus 2 upon root over 4 minus x square, which is root over x plus 2 upon root over x plus 2 into 2 minus x, or 2 plus x into 2 minus x. This gets cancelled out, you are left with under root 2 minus x. Clearly 2 is not belonging in the domain of f by g, so this quantity is real number for every x coming from the domain of f by g. Then you have f of x, this is very simple, f of root over x plus 2, right? This is fx into fx, it's actually that. It's a what? It is f into f of x. Pointwise product, root over x plus 2 into root over x plus 2, which is x plus 2 for all x belonging in the domain of f, which is minus 2 comma infinity. And then you have g into g of x, it is what? Root over 4 minus x square into root over 4 minus x square, which is 4 minus x square for all x in the domain of g, which is minus 2, 2. Fine. Moving to the next question we have, this is my function, draw the graph of this function. Now this is pretty simple, you can do that. See, we talk about the graph. When x is 0, you are getting 1. So when x is 0, you are getting 1. Suppose this is 1. Clear? When x is less than 0, the rule is 1 minus x. So less than 0, minus 1, you have minus 2, minus 3, minus 4. Fine? Minus 1. What is f of minus 1? F of minus 1 is 1 minus minus 1. 1 minus minus 1, which is 2. What is f of minus 2? 1 minus minus 2, which is 3. F of minus 3, 1 minus minus 3, which is 4. F of minus 4, 1 minus minus 4, which is 5. So you are basically getting what? Let me rub this. At 0 you are getting 1. At minus 1 you are getting 2. At minus 2 you are getting 3. At minus 3 you are getting 4. At minus 4 you are getting 5. So basically at 0 it is 1, at minus 1 it's 2, at minus 2 it's 3, at minus 3 it's 4, at minus 4 it is 5. So when you join them, you actually get this line. Similarly, if I talk about quantities which are on the right hand side of 0, that means they are positive. What do you eventually get there? You have basically, say, we just need to plug in 2, 3 values and you get the pattern. What is f of 1? 1 is greater than 0, so 1 will be mapped to 1 plus 1, that is 2. F of 2 is 1 plus 2, that is 3. F of 3 is 1 plus 3, that is 4. F of 4 is 1 plus 4, that is 5. So 1 gets mapped to 2, right? 2 gets mapped to 3, 3 gets mapped to 4, 4 is getting mapped to 5. So eventually you get this as your respective graph. That is the graph of y equals fx, where fx is defined in this fashion. Is it clear? Next question we have, define the function f by fx equals x square rule. Complete the table given below. What is the domain and range of this function? Draw the graph. So in here, when I complete the table, if x is minus 4, f of x is x square, minus 4 square is 16, minus 3 square is 9, minus 2 square is 4, minus 1 square is 1, 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. They have already given us several values. We need to use this to plot the graph. In here, if I plot the graph of y equals x square, I needed few values and their images under this particular function. I already have them. 0 is mapped to 0, 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 9, 4 is mapped to 16, minus 1 is mapped to 1, minus 2 is mapped to 4, minus 3 is mapped to 9, minus 4 is mapped to 16. Everything is being mapped to only positive reals and 0 is being mapped to 0. So your graph is going to come like this. This is y equals x square. You can clearly see corresponding to any real number in the domain, any real number you pick up, its image is coming out to be real only because you are just squaring it. And when you square it, your answers are coming as only non-negative reals, right? Therefore, domain of f is collection of all reals. There is no real number corresponding to which x square is non-real. You give me any real number, x square is a real quantity. That means all the real numbers are valid inputs. Therefore, domain is complete set of real numbers. But when I talk about range of f, range means answers. That means x square for every x coming from collection of all reals is a non-negative quantity. It is coming out to be only positive real numbers, or it is coming out to be 0. That means answers are always non-negative. So range of f is set of all non-negative reals. How do you write it? All those real numbers which are greater than equal to 0. Fine, and codomain is clearly collection of all reals. Okay, that completes our discussion over the questions. That's it from my side. Thank you.